Cool. Thanks for coming here. This is Composer in Depth, part 1. We're going to do a second part after the lunch break. And we're going to get started kind of the most of Composer, and the second part will go more into Packagist and getting Packagist into Composer. I guess there's more people coming, I think. Door should be open. Okay. So yeah, I'm Nils. This is Jordi. We've been working on Composer for over 7 years at this point. We started the project together, and we now run a company that offers private packages, which we'll point out in the second part a bit. So that's actually what we work on a day-to-day basis. Composer we call a dependency manager, and I want to start by just pointing out why we call this dependency management and why we prefer to use this term over calling it package manager. And that's because for our perspective, there's kind of an underlying big difference between those two things, where dependency management is more about managing the overall state of your application. So you're, instead of providing just install this thing, uninstall this thing, install this thing, you're kind of defining what are all the things that my application needs to run. And then Composer is responsible for making sure that all those things are present in exactly the versions that are needed and so on. So package management, from our perspective, is more this older state of how, like in a Linux distribution, you would go and say, hey, install like my web server, install this PHP extension. And it's kind of this manual process where you'd kind of, it's very error prone. It's very likely for you to make a mistake while you're doing this. And there's lots of different tools that kind of work like this. So it's very comparable to configuration management. So these modern tools that people use to manage their servers, like Puppet, Salt, Ansible, Chef, and so on, that all describe the state of the system as a whole and then find mechanisms to get the system into this state. So rather than telling it a list of instructions, you just say, these are all the things I need, and then the tool is responsible for figuring out itself whether it needs to uninstall something, upgrade something, downgrade something. Like, that's not really what you're telling it to do. And thanks. I just didn't realize that you were switching slides for me, but that's perfect. No, go ahead. It's like that just came as a little surprise. So to start with, I'm sure that you all at this point kind of have an idea of like what Composer does and how it works like, and that's why we're doing in depth here today. I just kind of want to go through, I guess, like the main workflow so that we're kind of all on the same page about how this works. And this visualizes all of that. So you'll see the main files that you'll interact with. There's the composer.json file on the left, the log file in the middle, and the vendor directory that actually contains the code that you end up working with on the right. And there's the two main commands that Composer uses, which are Composer install and Composer update. What you can see here is that these two things actually do two separate things. So the Composer install command will take a log file and make sure that the vendor directory contains exactly the files that you need to then actually run your application. The Composer update command is responsible for taking your composer.json file and generating a composer.log file. Now, Composer update will automatically then also trigger the install process. If you run a Composer update, you'll end up with files in your vendor directory, but that's because Composer update triggers the install afterwards. And the other thing that you can see here is that if Composer install is run without a log file present, because it doesn't know what to do, it'll go one step back and actually run an update. Right, so there's Composer update is the first step, Composer install is the second step, and this was always the case. So running an install without a log file is actually running an update. Running an update just also triggers an install afterwards. What you can see at the top is where different pieces of information come into this. The Composer update will go to Packagist to get information about all the different packages available, what versions are available, what dependencies do they have, and use this information to generate the log file. The log file will then actually contain all this information so that an install will just have to download the files, for example, off of GitHub and stick them in the vendor directory. Now, Composer has a lot of other commands like Composer require, Composer remove, which if you're working with it on the console, you're much more likely to run into. Now, these commands actually are just shortcuts to edit the composer.json file. A Composer require command is not a install this package command, because as I was describing, we're doing dependency management where we describe the overall state. So Composer require just changes your definition of the overall state and then runs a Composer update. Same thing for Composer remove. It just modifies the Composer.json file and then updates the whole thing.
All right. So now let's dive into how to work with libraries. I don't know how many of you have like a Contao library that you maintain, or like a plugin, I guess they're called, but I don't know. Anyone? Yeah, a few. Okay. So this is mostly for you, I guess. It's really the steps that we think are needed for publishing good packages that are, you know, usable by people and so on. So first of all, the README, that's really essential. Like that's your kind of, I don't know, like the business card of your package or something. It's like if there's no information in the README, people show up there and they go like, okay, what's, you know, what is this even doing? I'm not interested, and then they move on. So if you want people to use your software, the README is really something you want to take good care of. It should really describe in one line, like what is it doing. Kind of like using a story is nice, I think, like kind of trying to tell a story of what problem this thing you built is solving. Then basic instructions on like how to use it, and having like contribution instructions as well can be nice. If you're using GitHub, you can also have this in the contributing.md file. I don't remember exactly how it has to be called, but I think it's contributing.md. And if you call it that, then this will show up when people create a new issue, for example, or new pull request. So they get instructions on like how they can contribute to the project. Into that comes into play as well this whole story of code of conduct. I'm sure you've seen them in places. Like there are some as well dedicated to this kind of open source like contribution concept. And so Code Covenant, I think, is one of them. That's like kind of used everywhere, and that we use as well for Composer. And yeah, it just describes, you know, how to be nice to people on an issue tracker. Like that's the bottom line. Is like, just don't be an ass. But it's a bit more verbose. Then comes the big question of picking a license. I won't go into details there really, but a good resource is this SPDX, which is I forgot what the acronym stands for. Something software. Anyway, it doesn't matter. But it's a collection of all the like all the open source licenses and with like standard identifiers for them. So we enforce that at the Composer level. If you put something in the license field in the Composer JSON, it has to match one of those identifiers from the SPDX list. So they do include like the standard MIT, BSD, GPL, and so on. They have like standard identifiers for them, including the versions and so on. So just go have a look and find the one you're interested in. If you do not want to have any open source license, you can use the string proprietary, and that will then like still be valid even though it's not an actual license. Then another big part of the deal, like when you know publishing packages, is changelog, and I think it's just a big part of how you communicate to your users. The essential points really are the BC breaks. Like this, you must communicate correctly. Like if someone updates and they don't find any information on, like, you know, if you have a new major version and you don't have any information on what's breaking, like why is it a new major version then? Like this scares me when I see a new major version and no notes about BC breaks. I'm like, okay, I guess I'll try it out and see, you know, maybe something breaks. That is not a nice experience. So you really want to communicate on that. Then you have obviously like the list of changes, new features, bug fixes, and whatnot. Like this is nice to have. I think it's, you know, it's a good way to communicate to people, but especially really please include the BC breaks. Semantic versioning, I guess if you were in Sebastian's talk in the slot before, you've seen this already, but I'll quickly go through it. I guess you're familiar with it anyway, but it's just this concept of saying we have 3 versions separated with dots, and well, 3 numbers, and the first one indicates backwards compatibility. So if you break anything, you're supposed to increment the first number. If you add new features, you increment the second one, and if you just fix bugs, then you increment the third one. That's really the bottom line. Like, you can go on semver.org and read the whole document. It's like about 2 screens worth of information. It's really, it's worth reading because it's a contract between you and even if you're just using libraries, it's important to know the contract, right? So it's between maintainers and users, I would say. It's a way to communicate changes in code. Yeah, as I mentioned, like this concept of contract or promise of compatibility, like as long as the first number doesn't change, it should remain compatible. This is essential. And the flip side of that is that as a maintainer, if you do break anything, you really have to increment it. Otherwise, you're screwing with people. Like, and they will not be happy, and in the long term, that's going to hurt your project. So you really want to increment that whenever you break something. And there is no reason to be afraid, really. Like, it's, you're not going to run out of numbers anytime soon on the first, like on the X there. Like, this can go up to 10,000. It's fine. Like, I think you probably want to balance this a little bit, because if I look at Node, for example, and the whole like JavaScript ecosystem, some libraries tend to go like new major version every 2 weeks, and that's, I mean, at least they're being honest. It's good, but I think for users this is pretty exhausting, because it means like every few weeks you have to actually go check, okay, what did they break this time? Like, do I need to take care about this or not? Is this affecting my project? So this is not something I would recommend. I think if you can bulk the breaking changes together into like, do one breaking release every 2 years or something, it's better. I think it's easier, but do it however you feel like. Just don't forget to increment it. Yeah, another point there is to really define this contract in more details, because saying backwards compatibility, well, it's easy, but in the fine details, it gets kind of complicated. Like, I don't know, is adding a new argument to a function a backwards compatibility break? Like, technically not. If it's, if it's an optional argument, you could say, well, it's fine. But if someone is extending that class, then maybe their extending class is then breaking because they don't have the argument, and PHP is going to complain. So you can really argue there about lots of fine little details. And so one document that's a good example is this this Symfony BC promise document, and they do go into details into like everything, like what does it mean to the Symfony project to say, this is backwards compatible. And so you can go and you can read it and you can say, okay, like this is what they mean, and that's the contract. So having that, I think, is nice. Defining it all is quite time consuming. So for a small project, maybe you just want to point to theirs, or like, just copy paste it or something, because yeah, it's quite a lot of boilerplate otherwise. So for libraries, if you do continuous integration, which you should, obviously, I think one interesting aspect with regard to dependencies is to do like multiple runs with different versions of the dependencies. So you can have one that only does a Composer install, and so it takes the log file you committed, and it just like installs that and checks that it's working fine. But then what's especially interesting, I think, is the other two is to do an update so you get the latest version of all the dependencies. And that's like Sebastian was saying with the nightly build of PHP. It's a bit the same concept. It's saying, okay, like every time I build, I want to make sure that with the latest version of all my dependencies, things are still working fine. And this applies, like if you're writing a Contao plugin, you know, if Contao is a dependency, I guess, and like if they release a new version, it's better if it breaks your build immediately, because you notice it and you can fix it immediately. And hopefully, you know, your users didn't update yet to the latest version, and so they, like, you can fix it before it breaks on someone else's computer, and that's quite nice. The other aspect is to do this composer update with prefer lowest and prefer stable. So what this does is it kind of switches over the dependency resolution algorithm to say that we want the lowest possible version. The problem is this usually includes like beta releases and stuff like that, so you probably don't want to do that really, and that's why you also need the prefer stable, so that you go the lowest possible but also the most stable. So this gives you, like, it checks basically that your requirements are still correct, because if anything breaks with that build, it probably means that, you know, you say you're depending on like PHP 7.0, for example, but then you started using this new feature of 7.1 and you didn't think about it, but well, yeah, PHP won't actually be updated there, so it's a bad example, but you get the point. It's about testing with the oldest possible versions of your dependencies, if things are still running fine. And if you're requiring some new functionality, then you will need to upgrade your requirements. Yeah, another like extra thing you can do is to actually have multiple composer JSON and like do a composer update that way. With this composer environment variable, you can define, like, you can tell it to use another composer JSON file. So if you have like completely different set of dependencies for some reason, this happens sometimes. It's quite rare, and I would really not recommend doing that too often, because like it doesn't make using it any easier, and like it's fine for testing, but don't require your users to actually do this to install your project or something, because nobody's gonna be happy. Then the other side, which I guess concerns all of you, is working on applications. So for applications, versioning is not really a big issue. Like, unless you're actually publishing it, like if you're working, let's say, on Contao itself, then it's an application, but you're also, you know, you're actually publishing that to other users. So there you want to version things. But if it's just like one website you're working on, versioning doesn't really matter. Like, some people like to go and do tags regularly and like have even, you know, semantic versioning for their project. You can if you want, but really you're not communicating this to anyone else but yourself, and I don't think it really matters. So like for all my projects, it's usually just master branch, and we just ship that to production, and that's it. Like, no versioning. If you want, you can just increment a simple number, or yeah, just do anything you want. How do you update things? Well, so you can use, as we mentioned, this composer update that's going to update the dependencies, like update the log file and then install the latest dependencies. This is fine, but it's really fine only if you run it fairly frequently. Because if you run this once a year and then you're updating like 20 different packages, it becomes a bit difficult to pinpoint like what went wrong if something breaks. So if you don't do it so frequently, then you probably want to rather use this composer update with a list of packages. I guess that's the equivalent of in this in the Contao admin to go like, you know, selecting exact plugins you want to update, and that probably makes more sense if you're not updating every day, because that way you know exactly what you just did, and if something breaks, you probably know how to undo it easily, or like go check in which project for a problem. The dry run, well, they mentioned this in the keynote, so skip that. And yeah, so I mean, the driver and the advantage really is that you see what's going to happen, and then you can go inform yourself about, going to check the change logs of all these projects that are going to be updated, stuff like that. Like the best way to figure out what to update, if you want to do like this updating one by one thing, is to run the composer outdated command. So this last line there. So you run that, and it's going to check the latest version of all your dependencies, and it will show you, okay, you're using this version, there's this one available. It's just informative, but that lets you then choose, okay, I want to upgrade this one and that one. Then you can also see there's a new major version of that one, so probably there I really want to go check the change log, see what broke, if anything. Do I want to upgrade to the latest major version or not? It just lets you make a lot of decisions about all this. Just quick note about version constraints. So the first one, exact match, that's pretty self-explanatory. You just want one exact release, you get it. The wildcard is just really also fairly self-explanatory. Hyphen ranges are just like if you want an exact range of versions. This is not very often used, I think. The unbounded range, that's often used and probably often a bad idea, because there you're really just saying like, I want anything that's above version 1.0. And the problem is this also includes 2.0 and 3.0 and 4.0. And this is fine when you update tomorrow, but if you come to the project and update like a year from now, maybe you get version 3.x installed, and probably this breaks your project. So this is not really an accurate description of your dependencies, because you have no idea what's going to happen. Like this is not future-proof at all. Like it assumes that you know that in the future there won't be ever a 2.0 released, and that's just not reality. So what you really want in most cases is this caret operator. So the little hat, because this one, it always goes up from whichever version you say you need. So you just define your minimum version you need, and it allows to go up until the next major version. And it's basically like following semantic versioning for you. So that's usually what you want for any libraries that you're using, because you want, if they're following semantic versioning carefully, then this won't get you in trouble ever. If you need, you can use the AND or OR operator as well to combine things, but that's rarely used, I guess. So the OR probably for like PHP requirements, because you want PHP 5 or PHP 7, for example. But these days you really just want PHP 7, so that's not even needed anymore. And the AND is just a space. It's kind of a bit confusing, but it's just the space means AND. Yep. Then we have stabilities. So, like stabilities are just like the stability of a version basically, and so it goes from dev to stable, and all these steps in between with alpha, beta, RC. So for tags, this is just defined by the tag like that you have. So if you tag something like 1.2.3, well, it just means it's stable. If you tag it with dash beta something or dash alpha, then that's gonna be a beta or alpha. That's really simple to understand. But then for branches, like people like sometimes to call a branch like something alpha, and that doesn't work, because then it's renamed to like dev something alpha, because we force every branch to be a dev version. Because really, like, a branch is not, it changes, it can change at any time, so you can't rely on it as being anything else than a development version. Like, it's just a very fluid thing. Like, a tag is a point in time. You say, at this point in time, this is the code, and this is the version. A branch is just, it's always in development. So we enforce that all the branches are dev. If you want to choose the stabilities, you can have this this marker there with the @beta, so or like @alpha or @anything. So that just says, okay, I want a version like 1.3 point something, and I allow beta versions. Or like, well, by allowing beta, you always have to go back to this chain here, which says you allow stable, RC, or beta. So it's always beta or more stable, right? So this doesn't force the actual installation of a beta version, but it just allows it. So once there is a like 1.3.2 beta that comes up, it's going to be installed. If the 1.3.2 release comes out after, it's going to upgrade to that because that's more stable and it's better. The other option is to just require the exact version that you need, and then you don't need the @dev thing because that would be redundant. Like if you require explicitly something that's not stable, then we just allow it. And those are like a way to whitelist this kind of dependency, this stability for a given dependency. But then you can also change it for all of them. So if you define minimum stability to alpha, that means any dependency can be installed in alpha or beta or C. That's usually a bad idea because you don't really know what's going to happen again. And this also applies to like dependencies of your dependencies, and it's just like the effects can be pretty dramatic. So what happens if you get an error when updating? Just first step is to run Composer validate, because usually it does print some helpful stuff. Like it will go through your config and like cannot, check that your network is running and check that you have free disk space and check that, like it just checks a lot of things that are like common issues. I don't know if you can do that from the admin UI.
Nope.
But you should maybe. Andy, like. Yeah. It always works. Okay, good. Well, anyway, like I think being able to run this Composer validate would be a good idea. And yeah, actually, I'm kind of confused here. I see. I was thinking more of Composer diagnose. The diagnose runs all these network checks and so on. It validate only validates your project file. Sorry, but the effect is the same. That it does some like checks for you. It's a good idea to get started in debugging a problem. Then the things you want to do really is self-update to make sure you're running the latest version, and then try and update again with -vvv. That will output a lot of debug information and can help you as well, or at least it can help us if you report a bug. Yeah, just a quick mention there as well of a common like issue that we see a lot with like people publishing packages on Packagist.org is that they start off with having the version number defined in the Composer JSON, and you can do that because there are valid use cases to this. But if you're publishing to Packagist.org, then really the versioning is done automatically for you according to tags and branch names. So don't do that. Like just remove it from the Composer JSON. It's gonna save you some trouble, because if you define it and it doesn't match the tag name, then we ignore that version as invalid, and then people email us confused while their new versions are not appearing. So just don't do it. So just an example of like a conflict situation, and how you can maybe go about solving these. So in our project here, we require two packages: this Cool Alice and Lazy Bob, and these are the package definitions for those two dependencies. So they both require monologue, but in different versions, right? So if we try to install this, we get this kind of helpful output that usually people are not so keen on. I don't know. Maybe I'm just used to it, but I think it's fine. uh, so what it tells you here, like if we just walk through it, I think you will see that it's really not that bad. So first of all, it says your requirements could not be resolved to an installable set of packages. So that's a clear problem definition. And then there's a list of problems. So there's problem 1. Sometimes you have like 2, 3, 4. So there it says, okay, installation request. That means your package requested installation of something. So you requested Lazy Bob version this and Cool Alice version that. And these are satisfiable by these versions. So far, so good, really. And then it says, okay, Lazy Bob requires Monologue in this version, which is also satisfiable by some releases of Monologue. And then Cool Alice requires it as well, and this is also satisfiable. But there you start seeing the problem that these two sets of versions don't overlap at all. So that's the issue really here and why we get a conflict. So it says I can only install one of like 1.6.0 or 1.30 or this or that. Like it's just, it's trying to install them, but it can't install both at the same time because PHP doesn't let us do that, sadly. Like we can't have 2 classes with the same name in different versions of the code. Like this just does not happen. So the conclusion is to not install any of these because they just conflict with something else. And hence you get a problem. So how do you go about resolving this? Well, in this case, you really can't do anything except for updating one of these 2 projects. Like one of them has to, move on to allow some more releases. So if this one really requires 1.6, you probably want to move this one to allow 1.6 as well, or like, let's say, use the caret operator here instead of this wildcard, which would resolve the situation. So for that, you probably just send a pull request to one of the projects or something like that. Another like case here. So we have this this project that requires so it requires Monologue itself, right? So on the first line there, we require Monologue, and we require this bad package, which itself requires Monologue as well. But this one requires the dev master version, and that's really a bad idea. Like generally speaking, in a library, and you'll see why in a second. So at first, it's gonna say, okay, you try to install bad package dev master, and this is fine. We found it, but then this one actually requires Monologue dev master, and there's no matching package found. And then if you go on packages.org or something, you will see that there is indeed a dev master version for Monologue. So at that point, people are like, what the hell is going on? The error message also includes like a block that's not here, but it's of suggested things you should go check. And one of these is a hint that probably the minimum stability is wrong. So as you see here, we have a minimum stability of beta, which means we don't allow by default dev packages. And so bad package, it is in a version dev master, and by requiring it explicitly there, we allow that. But Monologue, we don't allow it to be installed in a dev master version. So these like dev packages are then filtered out entirely, and so that's why it doesn't find anything there. It just doesn't even know it exists because it's been filtered out. So how do you fix it? You just add here, like you see the add dev. You just say, okay, actually Monologue can also be installed in dev. That's fine. So if you do that, it's gonna install fine. The reason for that, because you're here requiring like 1.x, and dev master is not really 1.x, right? So we have this feature called branch alias, which kind of helps us resolve this issue of like branches not being numbered really, or like some branches. Like you can create a 1.0 branch, of course, but but like the master branch doesn't have a number associated to it. So this lets us reconcile this, and it lets you, as a maintainer, say that your master branch is actually equivalent to some amount, like some number. So this allows it to be installed, and it's all fine. But then, like, you know, a couple years down the line, again, you have a new major release coming out, and now the master branch is targeting 2.0. And this again will fail. Like, it's just suddenly your project starts failing, and the reason in this case being that, so you're still requiring monologue 1.x, and you allow the dev version, so you know it's fine. It's gonna try to install dev master, but like in this case, there's this dev master and there's 1.12, but there's no, like, they don't actually match anymore because master is not 1.x anymore, it's 2.x. So how do we fix this? Well, we can say, oh, well, you know, let's just require 2.x then, and that'll be fine. But that means you have to upgrade your project to use the monologue 2.0 version, and this bad package, you know, it's gonna still require dev master, but it doesn't mean anything anymore because it, like, if it hasn't been updated in 2 years, maybe the code is broken with the latest version of monologue. So you just don't know. That's why you really should avoid like requiring branch names like that, because it just doesn't mean much. So if you have other like errors of like something that's not updating, like if you're expecting it to update to the latest version of something but it doesn't happen and you don't really understand why, you can just ask Composer and say, Composer, why? And why this or why not that? And it's so if you say, okay, like, why do I have foobar installed because I don't understand why, like, I'm not requiring this, it's gonna tell you, okay, like, actually your dependency in version this and that requires it, so that explains it. Similarly with why not, you can also ask, like, why don't I have this version, like this latest version, why is it not installed? And it's gonna look at that version and say, maybe in this case that it requires, like, you know, the latest PHP version or something like that, and you don't have a high enough PHP version, so it cannot upgrade to this latest release. And that's stuff that people tend to just ignore, like, you know, they just want the latest version, they don't pay attention to maybe that the PHP requirement was increased. So this can help you figure it out. All right,
so after Jordi having walked you kind of through updates, errors, and how to potentially deal with some of those, the result is going to be the log file, as I pointed out at the beginning. Just to recap, the contents of the log files are all dependencies, including all transitive dependencies. That means every dependency and dependency of that and dependency of that, so on. Every single package that you end up getting installed into your vendor directory. It contains an exact version for each one of them, so not the constraints that we previously looked through, but the actual version that is installed. It contains the download URLs that includes the source, the distribution, so like a zip file it's downloading, like where the Git repository is located, potentially mirrors, and hashes of the files. And the purpose of this file is so that you can take it and go to another machine and install the exact same set of versions that you've previously installed, even though your composer.json defines a range of versions. This is useful if you're working in a team so that your teammates have the same versions of the packages installed. This is useful if you're building an application and shipping it to users so that they get the same versions. It's useful if you're deploying on a number of servers so that all the servers use the exact same versions. It also helps with isolating bug reports. Like if you're maintaining a library and you get a bug report, you can kind of figure out, is that because they installed a different version because their log file now differs, or is that because there's an actual bug in my library? It also adds transparency, because if you're committing this log file, like in your version control system, you will be able to see every time that another colleague updated something. Like without this, you wouldn't really know when updates happen. So the fact that we have this file lets us document all of this a lot better. So that's why it's so important that you must commit the log file to your version control system. So if you don't, as I was saying in the beginning, a Composer install will actually run a Composer update because there's no log file present. Now, conflicts, like we saw earlier, can happen during a Composer update. So if you're trying to do this as you're installing, like on a server or something like that, it can actually fail. You may end up with different versions installed. You may end up with different, things you didn't expect installed if you're running a Composer update. So really, you're not managing the change at that point anymore. Like it's just kind of happening as it wants to. So the whole purpose of the log file is to commit it to a version control system. Now, if you've done that, you'll run into conflicts. Who here has seen a merge conflict of the log file before? Like if they do this in Git. All right, a couple people. The reason that this happens, I'll kind of try and explain this here in a bit, is in my example, there's a master branch, which with this made up example of some animals as packages. And I have my branch on the right that I'm working on called DNA upgrade. Now, a colleague of mine is working on the master branch, and they're upgrading Zebra, and now as a dependency on Duck 1.0. At the same time, I'm still working on my branch over there. And in another week later, Duck 2.0 gets released. And a little while later, I decide to upgrade Giraffe 1.2 to Giraffe 1.2, which now depends on Duck version 2, this great new Duck release. Now you can kind of see at this point that there's a bit of a difference between the two branches, as I'm still working on my changes while someone in master updated things. So if I try and merge this back on a text basis, because if you remember, the log file is just a list of all the packages with their versions. So if I try and merge those two files, I would actually end up with an entry for Duck 1.0 and an entry for Duck 2.0. It's just a list of text files. I can just put them right in there. Now the problem is in PHP, you can't have like classes of the same name twice. You can't install two packages where it's the same package in two different versions at the same time. So this outcome would actually be a problem. And that's why we've kind of made the log file so that it will actually conflict anytime you try and do this, because you have to resolve this differently. What you should be doing is using a git checkout command, or you can use some UI, whatever you're using to interact with your version control system, to get the Composer log file from your base branch, the thing that you're trying to merge into, and then you kind of reset your thing to what was on the left side before, and then you rerun the Composer update command. And this gives Composer a chance to go and take a look that, oh, Zebra depends on Duck, but it's also compatible with Duck 2.0, so we can actually just install Duck 2.0 and it'll be fine for both of these versions. Or at this point, it could tell you that the only way to install this is to upgrade Zebra again. Like basically, there's a chance for Composer to figure out how to resolve this conflict. And the command that's useful here is to use the option with dependencies on the update. Like I guess you're rerunning the same command as before. So depending on what you were updating on your branch, you want to run the same update again. So in summary, the log file generally cannot be merged without conflicts. So even if on a text basis it looks as if that would be possible, you may result in incompatible dependencies. So that's why you always want to take the Composer log file from the base branch that somebody else was making changes to, and then run the Composer update again in the same way that you were doing it before. And once you've done all of this, like on the development side, you want to deploy your application, and I'll hand it back to Jordi.
Yeah. So I mean, he mentioned it, like you have to commit the log file, and once it's committed, obviously you shouldn't delete it before you deploy. Like this kind of makes sense, but you really want to deploy with the log file. Now, in terms of deployment, there are a few considerations, like for performance. One is to use this preferred dist flag, so that will just force it to use to download like zip files instead of cloning repositories. That tends to make things faster, just because cloning means you need to clone the whole history, while downloading the zip file you just download like the latest version, or like this one version you're interested in. So it already makes it a bit faster, but also if you cache the whole, if you cache, let's say, the cache dir between builds or between deployments, you have even faster performance there, because it's just like installing the zip from the local cache. So by default, it's gonna be in this directory on Linux, like on Travis CI or other CI like setups, you can usually these days there's a way to cache like things across builds, so that's the way to go to speed things up. Then we have like autoloader optimization as well, which is really important, like at the deployment level. So this will like make the whole autoloader much faster, and in some cases, I mean, it really depends on the application and how many classes you load and so on. But I think in on a kind of hello world application that does a really simple thing, autoloading can be really like up to 20-30% of the request time. So like if it's not optimized, and so that allows you to reduce quite a bit. So the first thing you really want to do is to install with -- optimize autoloader, or you can also do the optimization later on if you rather. So you can use the dump autoload command. Like these are really equivalent. It's just install will anyway do a dump autoload implicitly, but if you rather do the optimization later on, like after the build passed, for example, you can also do that. So that's the very minimum you should do, is this optimize autoloader. Like this will do like some basic optimizations, and it's already pretty good. But then you have two ways of going even further, and one is this class map authoritative, which says that if some class is not in this class map, like in this optimized class map we generated, then it doesn't exist. Like it says this is authoritative for, like it knows about all the classes, and if it's not in there, it doesn't exist. It doesn't make sense to go check on the file system at all. It's just not gonna find it. So this is fine, generally speaking, but it means that if you do any kind of code generation or something in production, that won't work, because it won't be able to find those new classes you generated anymore. And it also means that you shouldn't use this in development, because in development you want to be able to add a new class, and it should be able to find it immediately. You don't want to rerun a dump autoload every time you add a new class. So these are really only for production use, I would say. So if you do code generation, like you can use this APCU autoloader instead. It kind of works a bit differently, but it kind of works around that problem, but I think it's a little bit slower. So generally speaking, like use this class map authoritative if you can. That's the ideal option. This, however, requires PHP 7 to really work well. So otherwise, you still have a lot of like copies and like memory copying and going around and so on. So, but with PHP 7, this happens without like it happens really super fast. So, I mean, to be honest, if you care about performance, I think you must be on PHP 7 at this point. Otherwise, I don't know how much you're caring about performance, because like the upgrade itself will boost things so much that it's really worth it. Yep. Back to you. Oh, that's the thing.
Yeah, the other way. Okay, so as you're deploying, like another thing that will be of interest is something in Composer called platform requirements. I think this is a bit of a lesser known feature. In some sense, you've interacted with this probably. So first of all, there's a thing in Composer that's called a platform repository. So repositories are usually the sources that Composer packages come from, and we'll talk about this in part 2 this afternoon. But there's one special one that's defined in there, which you won't usually see, which adds all the packages that are kind of on your system outside the scope of your PHP libraries as read-only kind of packages. So that's your PHP package. Like there's something with the version, so that your dependencies can say they only work with a certain version of PHP. That's all the different extensions that you have installed, so that your dependencies can say they require a particular extension. But sometimes that's certain system libraries, like what version of libxml do you have installed. These things are just kind of like a fixed state, so Composer won't update these, won't be able to install new ones, won't be able to delete them, and so on. It's just kind of there so that other things can depend on them. If you want to take a look at what this looks like, you can run the command composer show -- platform, and it will actually list you all of these things that are on your system. So you'll see things like, I mean, all the extensions here, like APCU is installed here, like the date extension and the respective versions that they have. It'll list some of, like I said, like system libraries like curl is installed, libxml, OpenSSL, what version they're in. And it'll install, show you like which PHP version did I run this command on, but also some compile flags, like does this support 64-bit or IPv6 and so on. So all these things that you see in here, you can later on use as dependencies in your packages. Now, as a result of this, usually if you have a requirement for, let's say, PHP 7.1.1 here, and you're trying to execute the Composer update on PHP 5.6, it'll conflict because your PHP version does not match with the requirement of the packages. That's kind of the purpose of this. But the problem with this is if you're actually maintaining a number of projects, your local machine, you're running one PHP version on, but you're maintaining projects that get deployed to servers that use different PHP versions, then you may not really want to have this behavior because maybe you're still trying to update this one thing over here that's still running on PHP 5.6 while you're actually working on some other projects on PHP 7, so you locally have PHP 7 installed. So these kind of constraints no longer really match what you're expecting. Or, like in our case, where we're trying to build some automation tools around Composer where, we have a service that runs one version of PHP, but we want to be able to do this for all different projects that use many different versions of PHP. And flag was added to Composer Update that allows you to ignore these. So you can do Composer Update, ignore platform requirements, which will just not check any of them. So it'll just install any of these things as if the PHP definition wasn't even there. Now that's kind of helpful. It'll get it working in this case. But you now have no guarantee if either those packages even work with PHP 7.1, like you don't really know if this resulting set even works on there. And you also don't know if the things are compatible with each other. Because there could actually now be a package installed that works only on PHP 5 and one that only works on PHP 7.1. And the end result is that you have a set of packages that doesn't work on either version. So the better solution to this is to actually define the platform that you're trying to build the application for. So like this is kind of like, what are the PHP version on the server that I'm actually running this on later on? And then in your Composer.json, you can add a config section, which contains a platform section, where you can say the PHP version of my server that I'm running my site on is actually PHP 7.1.2, and there's the Intel extension installed of 1.1.0. And now if I run a Composer update, even though I'm on 5.6, which is not 7.1, it'll succeed and it'll have verified this. Because it goes 7.1.2 matches my constraint, 7.1.1, Intel has to be installed, this is all fine. So it like internally just checks that all these versions match up. The only constraint here is a bit, if you're using Composer plugins, this is a little dangerous because Composer plugins are basically packages just like any other one with a specific type and that contain code that gets loaded by Composer as it is doing the update or install. So this code gets run during the update install, meaning it gets run on wherever I'm doing the Composer update install. So if I'm running on 5.6 for the platform 7.1, the plugin still gets run on 5.6. So if you have a plugin that requires those versions of PHP, this will actually break the plugin. So it's just something to keep in mind. There's a lot of plugins that really, do very simple things with like files that'll just work on all these PHP versions. Like the typical installers that maybe modify directories that stuff gets installed into. But it's something that's important if you're making use of this feature that you know about. You can disable the plugins with the -- no plugins option, but there's no easy way to kind of later run them because they modify how Composer works, so you can't rerun them later. There are also Composer scripts. Like you can define them in your Composer.json. These are easy to turn off with no scripts, and then later you can use Composer run script to run this thing on the actual server that your site is running on. So those are kind of easier to deal with because you can just decide to, rather than running them while Composer install update is happening, you just run them later on. Same thing applies though. Like if the script actually requires the PHP version that you depend on, it'll not work. And the other thing that will happen if you just do what I just told you, maybe if you actually, you've defined 7.1 in your platform, but the site that or the server that you're running your site on hasn't actually been upgraded to that yet. You kind of, you already updated your Composer.json, but you forgot to do that there, or like this extension isn't actually installed. So after you've built your application, you've kind of zipped this up, uploaded it to your server, and you try to switch over to this new version, you just get a fatal error. In this example, like because the production server was actually still on 5.6. So what we did here doesn't work. So that's why there's another command that you can then run on the server that you're running your site on, called check platform requirements. And this will verify that the platform requirements down here that you've defined in your Composer JSON actually match what's running on the current machine, so that you can be certain that the result of what your packages required will actually be successfully running on the server. So in summary, there's our tip for library continuous integration is to run Composer update, prefer lowest, prefer stable. To run, if you're resolving a merge conflict, you should use get checkout branch Composer lock and rerun your Composer update. If you're trying to get your autoloader to be faster, you should be using Composer dump autoload -- optimize and potentially class map authoritative. If you're not sure what the reason for some package being installed or not installed is, use the Composer why and why not commands. You can use Composer show -- platform to get an overview of all the platform packages on your system, and you can then use the config platform definition to define your target platform. And then use Composer check platform requirements on the production server to verify that this is the case. And you need to be sure that you think about what plugins you're running there and what scripts and how you're going to deal with that. As library authors, please formalize your backward compatibility promises for users so that they can rely on semantic versioning. Make sure that you document this well. If you're using semantic versioning, don't be afraid to increment the major version, the X on there. Make sure that you always do that so your users can rely on the promise of semantic versioning, and make sure that all the changes you make to your dependencies get documented. And lastly, I guess, again, just make sure that you commit the composer.log file. Thank you very much. Or actually,
I think it's kind of lunchtime, no?
Yeah.
But I mean, if you have questions, we have another talk after lunch.
So I think there's going to be a longer section for questions after the second part anyways, and we're going to be around for the rest of the conference anyways. So with all your Composer questions, just come to us. We're happy to talk to you about all the details, any questions you may have. So thanks. See you after lunch.
Yep.